What are the most common thesis writing mistakes students make and how to fix them? Hi, I'm Elaine. I'm teaching in the university, and over the past years, I've guided dozens of students through their thesis and capstone projects. Well, I've made some of these mistakes myself back when I was working on my own thesis, so I understand the students and where they're coming from, the pressure, the confusion, and the desire to just build something cool without really knowing how to frame it academically. So, whether you're just starting your proposal or preparing for your defense, I hope this will help you create a clearer and more solid research output. Mistake number one, jumping to solutions without understanding the problem. So I've noticed that students design solutions that are not really in the proper context, or they don't really have the gap analysis, and they come in excited with an idea like an app, a system, a device, without really explaining what the real problem it solves. So example, I'll create a mobile app for health tracking, or I'll design a solar powered charging station. So these statements don't explain why those solutions are needed, what gap in the existing technology they are trying to address, or who the users are. So it's like giving an answer before really knowing the question. So how do we fix this, and how do we reframe this is to start with research-backed context. For example, this study aims to address the lack of efficient health tracking for rural users by developing a mobile app with offline functionality. Or, this project aims to develop a solar power charging station that meets the power requirement of remote communities where grid electricity is unavailable. So you can see that this reframes the idea within a clear problem context, and it identifies a specific user or need, which actually strengthens your both the relevance and justification. So now the idea becomes grounded in purpose, not just in innovation. Mistake number two, lacking novelty or original contribution. So oftentimes, students replicate existing systems or approaches without really introducing anything new or clearly stating what's the difference between the current study, the proposed study, versus the existing ones. So, example of this is an attendance monitoring system using RFID, or a solar battery charger with voltage monitoring. So if it's been done many times before and you're not really improving or adapting it in a meaningful way, it won't pass academic scrutiny. So novelty doesn't really mean that you're going to be creating or inventing something from scratch or something totally new, but your project should still make a unique contribution. Example of reframing or rephrasing this one. So we can say this study improves existing RFID attendance systems by integrating real-time data analytics for remote monitoring. Or this charger design includes a new hybrid algorithm that improves charging efficiency in partially shaded solar environments. You can see that this clearly state the value-added element, whether it's a technical innovation into the statement. So whether it's a technical innovation or contextual improvement, making the research more defensible and original. So your contribution can be technical, conceptual, or in the methodology, but it must be clearly stated and justified with your literature. Mistake number three, mismatch between the problem statement and objectives. So sometimes the objectives listed don't directly solve the identified problem. So this disconnect often weakens the whole logic of the paper. So example, the problem is students lack engagement in online classes, but the objective is to create a mobile app. Or the problem is energy harvesting systems lose efficiency during variable loads, and the objective is to design a low-cost prototype. So you can see that the solution isn't really clearly tied to the problem, and the reader is left wondering how the prototype or how this solution addresses the issue or the gap. So in order to fix this, you can say, to increase engagement, this study aims to design and test a gamified mobile app with interactive quizzes. Or, to improve efficiency, this study aims to design a low-cost prototype with an MPPT algorithm for variable loads. So these revised objectives now respond to the problem, and it creates now a clear alignment between your problem stated and your objectives, which is crucial for coherence and evaluation. So make sure that your objectives are laser focused on resolving the exact problem you identify. Mistake number four, objectives are not measurable or specific. So using vague action words such as improve or optimize without really saying by how much or how it will be measured. For example, to improve online learning or to make an efficient inverter. So these statements are too broad. There's no benchmark or metric to determine success. So to rephrase this, we can say to increase online learning engagement by 20% based on post-activity surveys, or to design an inverter with at least 85% conversion efficiency when tested on a 50-watt load. So these are now quantifiable and testable, which means you can objectively determine whether your goal has been met. Okay, which is very critical for academic precision. So remember that good objectives are smart, specific, measurable, achievable, relevant, and time bounded. Mistake number 5, methodology doesn't align with objectives. So sometimes the proposed methods don't actually support the objectives or provide the data needed to evaluate. For example, the objective is to evaluate learning improvement, but the method only builds a system without user testing. Another example is to measure inverter efficiency, but the method has no proper testing with real loads or efficiency measurement tools. So you can't say a method worked or failed if you don't test it properly. So ensure each objective has a clear and relevant method, such as to evaluate learning improvement, the study will conduct pre and post tests with 50 students. Or to measure inverter inefficiency or efficiency, the device will be tested under 50 watt and 100 watt loads using a power analyzer. So these revised methods now clearly match the objective and ensure you can gather the right data to support your conclusions. So always ask, does this method actually allow me to answer my research question or achieve my goals? Mistake number 6, weak literature review. So students often cite outdated or irrelevant references, or worse, they just summarize without really analyzing it. So example, apps are widely used in education, or solar panels can charge batteries. So these statements are too basic and don't really provide a strong foundation for your research. So you can rephrase this in this way. Recent studies in 2023 show that gamified apps improve retention by 15%, which this research builds upon. Or, based on IEEE 2022 studies, MPPT techniques increase solar charging efficiency by 20%, which this project adopts. So now, it shows you're building on up-to-date and relevant knowledge, which helps justify your project and demonstrate academic credibility. So make sure to use recent peer-reviewed and relevant studies to justify your work and show awareness of the existing knowledge. Mistake number 7, poorly written research titles. So it's either too vague or way too long. But remember, titles need to balance clarity and precision. So example of this is a study in solar panels, or a capstone project for the design and testing of a low-cost, efficient, user-friendly solar battery charger system. So you can see that one doesn't say anything and the other says way too much. So we can rephrase this by saying, design and evaluation of solar-powered battery chargers using MPPT, or gamified mobile app for increasing student engagement in online classes. Now you can see that these titles are concise but informative. They tell the reader exactly what to expect, which helps with both readability and searchability. So your title is the first thing that the readers notice, so make it count. Mistake number 8, failure to follow formatting or guidelines. So sometimes students make inconsistent citations, missing sections, or really not following the whole thesis template. So sometimes they mix APA and IEEE styles, or submitting a paper without an abstract, or they miss standard schematics or technical appendices. Now remember that your panelists will assume you lack attention to detail when they see this, and this is a big red flag in engineering. So make sure to use citations like Zotero or Mendeley to stay consistent, and also double check that you have all the required sections and you're following the format of the department. So proper formatting reflects professionalism and discipline. So it can influence how your work is perceived even before the content is evaluated. So these are the most common thesis writing mistakes that I encounter as an advisor and panelist, and trust me, they are all fixable. So the key is just to slow down and make sure that your problem, your objectives, and methods are all aligned. Add clarity, measure your impact, and always ask, is this contributing something valuable? And remember, clarity beats complexity every time. If this video was helpful, don't forget to like, share, and subscribe, and see you on my next video. Bye!